Welcome to Raw Perfect classes. In this video, I will discuss about matrices. First of all, you have to know that what is matrix. What is matrix? A rectangular array of numbers or functions or functions which are organized into rows and columns. That is known as matrix. What is matrix? It is a rectangular array of numbers or functions which are organized into rows and columns. That is known as matrix. How to represent matrix? We represent matrix by using symbol square brackets. What are the types of matrices? What are the types of matrices? What are the types of matrices? There are many types of matrices. First is row matrix. Second type, diagonal matrix. Third one is column matrix. Fourth, symmetric matrix. Fifth, skew symmetric matrix. Sixth, rectangular bracket matrix. Seventh, square matrix. Eighth, identity matrix. Ninth, zero matrix. Upper triangular matrix. lower triangular matrix. I think I have covered almost all matrices, all types of matrices. Now, first is row matrix. When we write this way, in which multiple columns, what row is 1, that is row matrix, like this 4 5 minus 1. Here we can see one row, 3 columns. Row is 1, column are 3, column 1, column 2, column 3, and here we write order, column multiply row multiply column, 1 by 3. We can say this row matrix is 1 by 3 matrix. In diagonal matrix, you can take row, 2 by 2 matrix, 3 by 3 matrix, in which you can see only diagonals values are given and other elements will be 0. That is known as diagonal matrix. You can see here, this is a diagonal, and order of matrix, that is 2 by 2. And in column matrix, column will be only 1, but row will be multiple, row 1, row 2, row 3. It's your choice how many you want to take rows. 3 2 1. You can see that here 3 rows and 1 column, that is column matrix. Now next is rectangular matrix, in which row and columns will not be equal, whether rows will be higher than column, or column will be higher than row, like this 2 by 3 matrix. You can see here 2 3 4 5 6 7, row 1, row 2, column 1, column 2, column 3. This is a rectangular matrix. Skew and symmetric matrix I will tell you later. Next is square matrix. When you write row and column equal, that is called square matrix, like this. Order will be 3 by 3, 2 by 2, 4 by 4, 5 by 5. That is known as square matrix, like this. 1 2 3 4 5 6 7 8 9. Identity matrix means when diagonal values will be 1 1, that is known as identity matrix. You can see here all values of diagonals will be 1. When all elements of matrix, whether they are diagonal or other elements, they all will be 0, that is known as zero matrix. Upper triangular matrix means when, just example, 3 by 3 order, you can see here 7 8 6 0 0 0 3 4 5. You can see here lower part of matrix from its diagonal. This is diagonal part. From there, in lower part, these 3 values, 3 elements will be 0 0. That matrix called upper triangular matrix. On the other side, lower matrix, in lower matrix, from diagonal elements above side values will be 0, 0, 0, 0. That is known as lower triangular matrix, and order is 3 by 3. Now, what type of operations will be performed on matrix? You can perform addition, subtraction, scalar multiplication, and you can say matrix multiplication. You have to keep in mind that when you want to add or subtract any matrices, 2 matrices, 3 matrices, their order should be equal. Means, for example, you have given A matrix 3, 4, 5, 6 and B matrix is given 1, 0, minus 1, 2. Both matrix order is 2 by 2. You can implement addition and subtraction on both. A plus B means 3 plus 1, 4, 4 plus 0, 4. 5 plus minus 1, 4, 6 plus 2, 8. If you want to implement subtraction, then 3 minus 1, 2, 4 minus 0, 4, 5 minus minus 1, that is 6, because 5 minus minus 1, minus minus plus. So that's why 5 plus 1, that is 6. 6 minus 2, that is 4. And you can see here, when order of matrices are same, you can implement addition, subtraction. And in case scalar multiplication, only you have to multiply one single constant value, whether that is alphabets or any number. For example, you have given this matrix 4, 3, 2, 1, 4, 6, 2. And this is a order of 2 by 3. And you have to find 2a. For 2a, you have to multiply whole matrix by 2, like this. 2 multiply 4, 8, 2 multiply 3, 6, 2 2s are 4, 2 1s are 2, 2 6s are 12, 2 2s are 4. You can see output will be this. And in case matrix multiplication, you have to keep in mind that column of first matrix, that should be equal to rows of second matrix. Then you can implement matrix multiplication. This is the rule for matrix multiplication. Means you can see you have given A matrix, that is 1, 2, 3, 4. This is 2 by 2. And B matrix is given. You have to keep in mind that column of first matrix, that should be equal to row of second matrix. You can 5 or 6 means 2 into 1. Its column and its rows, these are equal, so that's why we can implement matrix multiplication. A multiply B. How you can multiply? You take first row, first column. 1 multiply 5. 1 multiply 5, then put plus sign. 2 multiply 6. 2 multiply 6. And in second row, first column. 3 multiply 5. Then put plus, and 4 multiply 6. You can see output will be 5 ones are 5, 2 6 are 12, 12 and 5, that is 17, 3 5s are 15, 6 4s are 24, 24 plus 15, that is 39, and answer will be 2 multiply 1. This is a matrix multiplication. Now next, how do transpose of a matrix? Transpose of a matrix. In case transpose of a matrix, row convert into column, column convert into row. Means if you have given a matrix 5, 6, 7, 8 and you have to find transpose of this matrix, here we will use this symbol for transpose, and first row convert into first column, means row change into column. 5, 6, this is a row first and this one is the column 1. Row 1 change into column 1, and now row 2 change into column 2. 7, 8. This is known as transpose of a matrix. Now next most important point, that is what are the application of matrices? Where we use matrices? We use matrices. What are the applications of matrices? We use matrices for solving systems of linear equations. Second, we use matrices for representing transformation in geometry. Now we are discussing about row rank matrix, rank of matrix. Rank of a matrix. What is the rank of matrix? The number of linearly independent rows or columns it contains. We can say it indicates dimension of the vector space, the vector space which spanned by rows or columns. The rank of a matrix is the maximum number of linearly independent rows or column in matrix. What is linearly independent? Linearly independent linearly independent means when rows or column can be expressed as a linear combination of others. How to find rank? How to find rank of a matrix? First method is echelon form, in which we use row reduced row echelon form. Second, minus. Echelon form means one method to find the rank is to reduce matrix to its row echelon form. The rank is then equal to the number of non-zero rows in the echelon form. In first method, rank is equal to number of non-zero rows in the echelon form. Second is, in second method, rank can also be determined by finding largest square submatrix. Largest square submatrix. With a non-zero determinant. Means a non-singular minor. You have to keep in mind that how to find the rank of a matrix. First we will use echelon form method, second minor. In equivalent form method, we will find rank by rank will be equal number of non-zero rows in the equivalent form. And in a minor method, largest square submatrix with a non-zero determinant, we will find rank, that is non-zero, non-singular minor. You should keep in mind some main basic points, that is rank of a matrix cannot exceed the smaller of number of rows and column. Rank of a matrix cannot exceed smaller of number of rows and column. Second, zero matrix has a rank of 0. You have to keep in mind that first, rank of a matrix cannot exceed the then smaller of the number of rows and columns. Okay. Second point, you should keep in mind that zero matrix has a rank of 0. Third, rank of identity matrix. Which is identity matrix? In which diagonals will be 1 and other elements are 0. 1 1 1 0 0 0 0 0 0. This is a identity. Sorry. I have given wrong example. This is not a identity matrix. This is a scalar unit matrix. Unit matrix. No, I am right. Identity matrix in which all diagonals will be 1 1. It is also known as unit matrix. Now next point is, in case rank of identity matrix is equal to its dimension. Okay. Now fourth main point, that is rank of a matrix is the dimension of vector space. Rank of a matrix is dimension of the vector space which is spanned by its rows or columns. What is spent? Spent in matrix, you can say span means column and rows of a matrix, means set of all possible linear combination of vectors. What do you mean by spant? Means set of all possible linear combination of those vectors. And span means a span of a set of vectors is the collection of all vectors which can be obtained by taking linear combination of those vectors. Now, you have to keep in mind some basic points, that is rank of a matrix means submatrix of a given matrix. Either that matrix itself or a matrix which is obtained from given matrix after deleting some rows or column, or both. Means, for example, you have given 4, 5, 6, 7, 8, 9, 3, 2, 1. I have delete this first row and this column, and I have find this submatrix. A is equal to 7, 8, 3, 2. This type is called rank of a matrix. Means this is a submatrix. Given matrix is given by 3 by 3 order. Now you have find submatrix 2 by 2 order. Submatrix of a given matrix. This is a submatrix and this is a given matrix. I have find this submatrix from this given matrix. So rank of a matrix means submatrix of a given matrix is either matrix A itself or matrix obtained from this A after deleting rows and column, or both. Second, the determinant of an row square submatrix is called minor of order R of a matrix. Means when we find determinant of this submatrix, that is known as minor of order R of a matrix. You can represent determinant like this. 7 multiply 2 minus 3 multiply 8. 7 2s are 14, 3 8s are 24, 14 minus 24, that is minus 10, and this minus 10 is a known as minor of order R of a matrix. Third one, you have to keep in mind ready to rank of matrix. If every row minor of a matrix is 0, if you have find 0, then every minor of order higher than R is also 0. Now we are in a position to define rank of a matrix. Now, what is the definition of rank of a matrix? A number R represent, this small r is represent to rank of a matrix. A number R is said to be rank of non-zero matrix A. Non-zero matrix means that matrix in which all elements are numerical number rather than 0, which does not, if there exists at least one minor of order R of A which does not vanish. Every minor of order R plus 1, if any, vanishes. The rank of a matrix is denoted, and how can represent rank of a matrix? Rank of a matrix represent by this symbol, and that should be equal to R. Another definition of rank of matrix, that is rank of a non-zero matrix is the largest order of any non-vanishing minor of matrix. It means the rank of zero matrix is 0. Rank of zero matrix is 0. Rank of n into n matrix, non-singular matrix, is n. Rank of matrix less than equal to R if every minor of order R plus 1 vanishes, and rank of matrix is greater than equal to R if there is a minor of order R which does not vanish. Rank of matrix is transpose equal to rank of matrix equal to equivalent matrix means when an elementary transformation which is applied to a matrix, their result matrix of same order, same rank. The resulted matrix is called equivalent to the given matrix. We use the symbol to obtain symbol tilde symbol to mean has the same order and rank as or is equivalent to. Now we are going to take one example which I will discuss with you related to rank matrices. For example, we have given values 1, 2, 3. -1, -3, -3, 0, 0, 1. This is given 3 by 3 order, and it represented by A matrix. Now we have to find its determinant. How can you find the determinant of this matrix? First of all, you have to take from first row first value outside of sub matrix. Now leave first row first column. You will find -3, -3, 0, 1. Now you have to take symbols like this: plus, minus, plus. Here minus, plus, minus, plus, minus, plus. Now you can see here symbol will be minus. So take here minus symbol. And now take -1. -1. Now this time first row will be cut, but second column will be cut, not first. Here value will be 2 and 3. 2, 3. And here 0 and 1. After that, what will be the sign? Plus. And what will be the value in first row? 0. Now take first row will be cut, last column will be cut, and value will be remainder this: 2, 3, -3, -3. Now solve it. How to multiply? Take top element, means first element. This element represent to A11, this represent to 12, this represent to 21, this represent to 22. So here we will take formula: A11 multiply A22 minus A21 multiply A12. So -3 multiply 1 and take sign minus. Again -3 multiply 0. Minus minus plus 1. 2 multiply 1 minus 3 multiply 0 plus 0. 2 multiply -3. 3 multiply -3. 3 ones are 3 minus 3. 3 0 0. 2 ones are 2. Minus 3 0 0 0. 2 3s are 6. 3 3s are 9. Minus minus plus. 3 minus 0, 3 minus 3 minus 0 minus 3. Multiply by 1 minus 3. 2 minus 0 2. 2 multiply by 1 plus 2. When we multiply 0 with any number, then number will be 0. Minus 3 plus 2 minus 1. You can see here determinant is not equal to 0. So we can say A matrix which is given is non-singular matrix. So rank of A matrix is, but what is the order of this matrix? 3. So that's why rank will be 3. In this video, I have taught you how to find rank of a matrix. You should keep in mind that if if determinant will be equal to 0, that means A matrix is not non-singular matrix, means ki singular matrix. Then we have to find minor of order, that will be equal to rank matrix. In this video, I have started this chapter matrices. In next coming video, I will continue this topic. Thank you. If you like this video, then like and share my channel with your friends so that they can take benefits from these videos. Thank you.